Okay, so here are just some basic problems from section 6.9 or 6.5 inverse trig functions. Actually, the first thing I'm going to do is on this first video go through the kind of general derivations of these derivatives, and then the next video I'll be going through examples, so you can watch both of them separately if you need to. But the first thing the book brings up and goes through is pictures of the inverse trig functions. This is in the book. You can look through this all you want. But the key is this: y equals sine x, or inverse sine of x, or arc sine x, whatever you want to call it, if and only if the sine of y equals x. So again, these are undoing each other. Same thing. We also call arc sine as the inverse of sine, both of them. Okay, arc sine, inverse of sine, or arc sine of x. Here's inverse cosine. Again, y equals inverse cosine of x if and only if cosine of y equals x. And here's the graph of cosine x. Here's the graph of the inverse. Same thing with tangent, if and only if tangent of y equals x. And these are important because these are going to go through the derivations for us. Again, here's tangent's graph, here's its inverse graph. And then inverse secant of x if and only if secant of y equals x. Now, here's the first thing. How we derive y equals inverse sine of x. So what we actually do is we start off with this statement. That's why it's important that we have sine of y equals x. So sine of y equals x. And we use the implicit derivative. So the derivative of sine, so we do d dx of both sides, but that means you have to do the implicit derivative on the left side. So it gives us cosine of y times the derivative of the inside, which is y prime. And then the derivative of x is just simply 1. Okay. Well, then now I've got y prime or cosine of y times y prime. So divide by cosine of y. Okay. Problem with that is I'd not define this function in terms of y, and especially not in terms of cosine y. But I know that cosine squared y plus sine squared y has to equal 1. That's my Pythagorean identity. So subtract sine squared. Take the square root of both sides. There we go. 1 minus sine squared y. So y prime equals 1 over 1 minus sine squared y, which still isn't great for us because sine squared y doesn't mean anything. It's still in terms of y. You can't have y prime in terms of y. However, it's up here. You're missing it now. But way back at the beginning, we said sine of y equals to x. That's what inverse sine actually means. So this guy here I'm going to replace with x, which means instead of being sine squared y, it's going to be x squared. So that's actually, sorry, I'm running out of space there. So there it is. The derivative of the inverse sine of x is 1 over square root of 1 minus x squared. Okay. Now, we can do the same thing with cosine if we want. That's the next one to derive, is cosine. So cosine, you do the same thing. I'll do this in red to make that kind of first part stand out. The cosine of y equals x, okay, given y equals inverse cosine of x. So if we have the inverse of cosine, really, that means cosine of y has to equal x. So we do the derivative of both sides. Which means we'll do the implicit derivative on the left side. So that'd be negative sine of y times y prime equals 1. Y prime therefore equals negative 1 over sine of y. I'm just going to move that negative up to the 1, put this over sine of y. Well, hey, wait a second. I don't like this in terms of sine, and I don't like it in terms of y. So we go back. Fine. Cosine squared y plus sine squared y equals 1. Do the same thing, solve for sine of y. Okay, so 1 minus cosine squared y. So y prime is negative 1 over square root of 1 minus cosine squared y. But again, in terms of y, I don't want this. But hey, cosine y was x to begin with, so replace that with x there. So the derivative of inverse cosine of x is negative 1 over, whoops, running out of space here, 1 minus x squared. Okay. And so these two guys really are the exact same, the inverse of sine and the inverse of cosine, except for positive 1 here. Nah, running out of space. Let's put next to it, they're like this. Yeah. Positive 1 with sine, negative 1 with cosine. Okay. Now, next one to do is tangent. So again, given we have y equals tangent of x, we will define inverse tangent of x as, given this, we'll just define this as tangent of y equals x. So again, do our implicit derivative of both sides. I'm just going to be lazy in notation because it's same video or same thing. Okay. Well, this will be the derivative of tangent, which is secant squared times y prime. This will be 1. Divide by secant squared y. And you go back and say, well, what the heck does secant squared y equal? Oh, well, there's an identity which we haven't seen for a while. Secant squared y is tangent squared y plus 1. So I'm going to replace that with this. And we said, what's tangent squared y equal to? Oh, it's really equal to x. So the derivative of inverse tangent is simply 1 over x squared plus 1. Okay. And then, by the same exact thing, I can do is inverse cotangent. The derivative of inverse cotangent is negative 1 over x squared plus 1. Okay. And then our last couple to sort out are secant and cosecant. So again, we're going to define if y equals inverse secant of x, we will define secant then of y equals x. Okay. So do the derivative of both sides. That gives us secant y tangent of y equals 1. Okay. Well, we already know what secant y was. It was just times y prime. Times y prime. Well, that's easy enough. We know that secant y is equal to x. So it'll just be x times tangent of y times y prime equals 1. And okay, well, that again, it's in terms of tangent there. That's a problem. And I'm going to do all the algebra stuff now real quick. But we go back to that trig identity that secant squared y will equal tangent squared y plus 1, which means I can solve for tangent y by subtracting 1 and squaring it. And again, we already know that secant of y is x, so this is really x squared minus 1 equals tangent squared of y, and then take our square root to solve for tangent. We get x times the square root of x squared minus 1 times y prime equals 1. Divide by this guy. There we go. dx of inverse secant of x is 1 over x times the square root of x squared minus 1. And then inverse cosecant is negative 1 over x times the square root of x squared minus 1. Okay. So there are our inverse trig identities, or derivatives, sorry. And then Here's a whole table of them. Okay. So sine is 1 over 1 minus x squared, square root of that. Cosine is negative 1 over square root of 1 minus x squared. Tangent is 1 over 1 plus x squared. Inverse cotangent is negative 1 over 1 plus x squared. Secant is 1 over x times the square root of x squared minus 1. And then inverse cosecant is negative 1 times x times the square root of x squared minus 1. There you go.